This is Scott Palmer representing Group 6. Now to present Chapter 10. In this slide, we will go over the importance of performing automated testing. It saves time and energy on writing code and testing those codes. That is well explained in the Google case, where there was a problem with Google Web Server team that prevented them from making any changes to the server, which resulted in bigger issues that affected the testing for reliability and testing time prolongation. Here we look at performing continuous build tests and integration practices and environments. As mentioned in the previous slide, the importance of automated testing in daily work, it creates fast feedback loops so servers can discover the problem early in the process and fix it. When automated testing becomes continuous, it increases the frequency of integration and testing of the code. According to the image, it is done by building the deployment pipeline, which will perform integration of the code and environments and trigger a series of tests every time a new change is put into version control. We must create automated build and test processes to achieve that. This is critical for the following reasons. 1, the process could run all the time. Next, a segregated build and test process ensure that we understand all dependencies required to build, package, run, and test our code. Next, we can package our application to enable the repeatable installation of code and configurations into an environment. Next, instead of putting our code in packages, we may choose to package our applications into deployable containers. Last, environments can be made more production-like in a way that is consistent and repeatable. Deployment pipeline provide the infrastructures that allow continuous integration practices to run. In the deployment pipeline stage, the automated tests are run as well as validation, such as code analysis, duplication, and test coverage analysis and checking style, which allows the acceptance stage to automatically deploy the packages created in the previous stage, which was the commit stage. Through each stage, the code could be deployed into production, providing everyone in the value stream, especially developers, the fastest possible feedback. Continuous integration practices now come in place to validate the deployable state. In a project, there are various stakeholders that are involved, like the developers. Problems can be fixed in a timely manner when we implement fast automated services versus if testing takes time and the feedback is slow, which expose the system to not be effective and the difficulty of successfully identifying the problem. Now let's discuss automated tests. If it consists of unit tests, these typically are singular tests, which means only testing for single content such as method, class, or function in isolation. This happens to keep our tests fast and stateless. The acceptance test, the objective aspect of acceptance test is it doing what it is supposed to be doing, meaning the customer needs are being met. Integration tests. Integration tests are where we ensure that our application correctly interacts with other production applications and services as opposed to calling stubbed out interfaces. When we look at this slide, we will see that the priority is the errors to be found with the fastest category of testing possible. But how can we deal with errors that are found in our acceptance and integration tests? We should create a unit test that could find the error faster, earlier, and cheaper. Martin Fowler described the notion of the ideal testing pyramid, which states that we could realize the errors using unit tests. We also create a more loosely coupled system in case it is too difficult or expensive to write or maintain unit tests. It's likely that we have an architecture that is too tightly compounded where strong separation between our model boundaries no longer exist. To achieve the purpose to have fast the tests, we need to design our tests to run in parallel, potentially across many different servers. As we see on the slide, we may or may not allow manual exploratory testing. We can determine that when all the automated tests have passed, which will provide faster feedback and allow manual testing on builds that will eventually fail. One of the most effective ways to ensure we have reliable automated testing is to write those tests as part of our daily work, using techniques such as test-driven development, TDD, and acceptance test-driven development, ATDD. This technique was developed by Kent Beck in the late 1990s. The test has these main steps: ensuring it fails, which means writes desired functionality and checking in. Then ensuring it passes and checking in, then reconstructing the coding, then ensure it passes the checking in again. These automated test suites are checked into version control alongside our code, which provides a living, up-to-date specification of the systems. When we look over this slide, we see that the most preferable way is a small number of reliable automated tests because they are the most reliable. That's because large automated manual tests may create undesired outcomes and could generate false positives. We need to test every change made to our code base as early as possible. That allows developers to continuously integrate new or changed code into a shared repository and verify it with an automated build. These tests are run continuously, enabling teams to detect errors quickly and locate them early and easiest. It's easy to run. These tests vary every day or even hourly. And if there's failed unit tests or any other build step, the CI tool won't allow you to continue. Non-functional testing is done to verify the non-functional requirement of the application, like performance, usability, etc. It verifies if the behavior of the system is as per the requirement or not. It covers all the aspects which are not covered in functional testing. This testing has a greater impact on applications when it comes to the performance of the application under high user traffic. This testing ensures that your application is stable and can handle the load under extreme conditions. The sole purpose of this type of testing, is to ensure that the non-functional aspects of the application are tested and the application works well in context to the same. The purpose is to cover the testing of all characteristics of the application, which will help to provide an application that meets the business expectations. And Core gives the worker the ability and moreover the empowerment to stop production when a defect is found and immediately call for assistance, which result in stop of production until the problem is fixed. Using add-on Core gives every member the authority to roll back and get back to the green stage, which is the deployable field, so they can make the changes and fix the problem. Let's take a look at the importance of pulling out the and-on cord. When the and-on cord is pulled, it becomes a hassle to make everything work again. The problems here are discovered in the production stage, which makes the deploy and environment unreliable. In this presentation, we went over automated testing and the benefit of it. Thank you for listening.